Hello, my lovely college algebra class, and welcome to the video going over 10.4, the Algebra of Matrices. Before we begin, I wanted to go over a quick review of elimination, because we'll be using that in today's main lesson. So for elimination, of course, we need either the x's or the y's to have opposite numbers. Opposite numbers, meaning I have to have either the coefficients be positive 12 or negative 12, 10, or positive 10. That's what I mean by opposite numbers. And as right now, neither my x's nor my y's have opposite numbers. But what if I take the top equation and let's say I multiply everything by -2, and then let's see what happens. We distribute that -2 to the top, and that'll give me -12x plus 8y equals -60. And once I have that, sure enough, the top equation now has a -12, while the bottom equation will have a positive 12. So now I have opposite numbers. I have the -12 and the positive 12. Once we have those, we're done with step 1, and we can move on to step 2. Step 2 is when we got to combine all the like terms. Combine the x's, which will cancel. Combine the y's, +8 and +5, to give me 13y. And then I can combine the constants, -60 and -18, which if I combine will give me -78. And once you have that, you see here, you now have a perfectly good equation that you can solve for y. And all that you have to do is divide by +13. So -78 divided by +13 will give you y equals -6. So we're off to a good start. However, we are not done yet. We still need to find our x variable. And lucky for us, to find our x variable, it's as easy as plugging and chugging. Like for example, let's say I'm going to take this equation. 12x plus 5y equals -18. What if I just go ahead, take my y equals -6, plug -6 in for y? So then when I do that, my equation will now become 12x plus 5 times -6 equals -18. Which then if you solve for that, 5 times -6 will be -30. And then from there, all you gotta do is just solve for x. Add the 30 to both sides, which will give you 12x equals +12. Then, of course, you solve from there, you'll get x equals +1. So there you go. You have your two solutions, x equals 1 and y equals -6, which, if you all well remember, I'm just going to write it over here, we always answer that as an ordered pair, where the x will put in +1, and for the y, we'll put in -6. So just a little review on elimination, because we will be using that in today's lesson over the algebra of matrices. So with that said, let's move on to the next slide. So most of the stuff you've already learned before in Algebra 2, but maybe we might need a little refresher. For example, matrix addition and subtraction. Two matrices can be added only when they have the same number of rows and the same number of columns. For example, if you look at our first example, if you notice, the first matrix is a 2 by 3, meaning it has 2 rows and 3 columns. The second matrix is the same thing. It has 2 rows and it has 3 columns. So as long as these two matrices match, we can add or subtract them. And of course, when you add them, your final answer will also be a 2 by 3 matrix. And you probably guessed how we get to add these together. You'll first add the 1 and the -7 together because they are both in the same spot. And when you add them, you'll get -6, which will also be in the same spot as the 1 and the -7. You do the same thing for the other numbers. Add the 2 and the 0 together to get 2. Add the 3 and the -2 to get 1, so on and so forth. And you can probably do the rest on your own. And you can double check with my answers. For the last row, you'll get 7, 10, and 5. And that's it. You're done. Easy as that. Nothing more to think about. Now, the second example, however, if you notice that our first matrix is a 2 by 3, but the other one is a 2 by 2. And sadly, we cannot add or subtract matrices that have different dimensions. So that one is not possible. And that's all you gotta do. Just say not possible, move on. So with that said, let's move on. Now let's take it up a notch. Given these two matrices, we want to write 2a minus 3b as a single matrix. Now let's take a look at that. 2a minus 3b. When you see the 2 in front of the a, that's actually saying that we want to take matrix, the number 2, and then we want to multiply that number to matrix A, which if you look up here, matrix A has the elements -1, 6, 2 and -8, 0, 1. And then, of course, we're then going to subtract that from 3 times B, where in this case, we're going to take 3 and multiply it by matrix B, which has the elements 0, -3, 4, 1, -2, and 6. Now, just a refresher, anytime you're taking a matrix and you're multiplying it by a scalar number, all you have to do is take that number, like in this case, take number 2, and you distribute it to each element in your matrix. So if we do that for this one, if we multiply the 2 to every element in matrix A, we should get -2, 12, 4, and then -16, and 2 times 0 is 0, and then 2. Rinse and repeat for 3 times B. All you gotta do is just take the 3, distribute to each element in the matrix. And then let's see what that gets us for the second part. 3 times 0 is 0, and then -9, and then 12, then 3, -6, and then 3 times 6 is 18. There you go. All you had to do is distribute the 2 and the 3. Now that's all left for you to do is subtract the red matrix from the green matrix. And lucky for us, they both have 2 rows, 3 columns, so we can subtract them. So -2 minus 0 will give you -2, and then 12 minus a -9, which actually, if you think about it, that becomes plus +9, which will become 21. Then 4 minus 12 will give you -8. -16 minus 3 will be -19. 0 minus a -6 becomes plus +6, which gives you 6 in that spot, and then 2 minus 18 will give you -16. And that's all there is to it. Again, literally, this is review from Algebra 2. We did problems exactly like this back in Algebra 2 last year. So, nothing new for you guys. And now moving on. This may be something new to you. And rest assured, it's not as hard as you think. Let's first start with what we know how to do, because we know how to take a number 3, the number 3, and distribute it to each element in the matrix. Let's go ahead and do that. So then 3 times -x will be -3x. Do the same thing, then you get -3y. and then you'll get negative 3z. Awesome. And then we're going to have minus, and then here we're going to have a positive 4. Don't be confused. Don't think of that as a negative 4. Think of it as a minus and then a positive 4 being distributed to each element in the next matrix. Do not fall for that. I know it's tempting, but do not do it. Think of it as a positive 4, not a negative 4. Then 4 times 2x will be 8x, and then 4 times negative y will be minus 4y, and then 4 times 3z will be positive 12z. So all of that is going to be equal to 0, negative 8, negative 105. Okay, so now we've just distributed. Now the question is, how are we going to solve? Or in other words, how are we going to find what x is equal to, what y is equal to, and what z is equal to? And that, ladies and gentlemen, is actually not as hard as you think. Well, think of it this way. The negative 3x and the positive 8x are in the same spot, and so is the 0. They're all in the first spot of each matrix. So if that's true, wouldn't we be able to line them up in their own specific spots? Like, for example, let's do negative 3x and then minus the positive 8x, and then set that equal to the 0. Oh, look, a perfectly good equation that we can solve for x. We can do the same thing with the middle parts, the negative 3y, the negative 4y, and the negative 8. Let's pair them all up. The negative 3y minus the negative 4y equals the negative 8. And then last but not least, you have the third elements, the negative 3z, the 12z, and the negative 105. They're all on the third spot of each matrix, so we can pair them up. And you'll get negative 3z minus 12z, all equal to negative 105. And all that's left for you to do, take these 3 equations, and then let's solve. So I'm just going to erase these over here to make room. We'll take a look at the first one. 3x minus 8x, that should give you negative 11x, all equal to 0. Then to solve for x, just divide by negative 11, which, of course, doesn't change anything. We will still get x is equal to 0. Moving on to the next equation. Negative 3y minus a negative 4y. Well, if we change that to plus positive, negative 3y plus 4y, that'll just give you 1y equal to negative 8, which you divide by 1, you basically still get the same answer of y equals negative 8. All right, almost done. And then last but not least, negative 3z minus 12z, which will give you negative 15z, all equal to negative 105. And then all that's left to solve for z is divide by negative 15. And then double check that real quick. Negative 105 divided by negative 15 will give you z is equal to 7. And there you go. You have your x, you have your y, you have your z. You're done. You see, it wasn't too bad. Just distribute and then pair up the numbers in the same spots, and you're good to go. So with that, moving on. All right, a similar problem, but it might require a little bit more computation. So let's begin. So for the first element, or for the first scalar matrix, or scalar multiplication, again, just distribute the 2 to both elements in the matrix, which should give you 6x and negative 10. And then let's do the same thing to the second matrix. And they're going to be added. There you go. So 2 times negative 17 should give you negative 34. And then 2 times negative y will be negative 2y. And all of that is still going to be equal to 2y and 2x. And just like I said before, depending on which spot each of the elements are in, we can pair those together. For example, the 6x and negative 30y, or the 6x minus 34 and the 2y can be paired up. So let's go ahead and do that. 6x and then plus a negative 34, or in other words, minus 34. That's going to be equal to 2y. Then do the same thing to the bottom equations, or the bottom parts. The negative 10 and then minus 2y equals 2x. Okay, so we're off to a good start, and we need to figure out what y and x is going to be equal to. And I don't know about you, but I would feel a lot more comfortable if the equations were written in order. Or in other words, let's pair up the x's in the front, the y's in the back, and the constants on the right side. So I'm going to take this equation first, the top one. I'm going to rewrite it by subtracting the 2y to both sides, and then go from there. So I'm just going to take that over here. So we'll get 6x minus 2y minus 34 equals 0. And then from there, I can add the 34 to both sides. So then I'll get 6x, oops, I had to put that in red. And then you'll get 6x minus 2y equals 34. And then if you do something similar for the bottom equation, you should end up getting negative 2x and then minus 2y, all that equal to positive 10. Again, you can do that part on your own, rearranging the x and the y and the constant to make sure that it's in order. Okay, so now the x's are in the first, the y's are in the middle, the constants are last. And you can probably guess what we're going to have to do to get the x and the y. Yeah, guessed it, we got to do elimination. So there's multiple ways you can do elimination. You can either cancel out the y's or cancel out the x's. I am going to go ahead and cancel out the x's. So in other words, I'm going to multiply the bottom equation by 3 and go from there. So the top equation, I haven't touched yet. But for the bottom equation, I'm going to multiply it by 3, and I'll get negative 6x minus 6y equal to 30. So then from there, I can combine my like terms. The x's will cancel. My y's will combine to give me negative 8y. And 34 and 30 will combine to give me 64. Ooh, look, a perfectly good equation that I can solve for y. And I will end up getting that y is going to be equal to negative 8. Okay, so I have my y. All I need now is to find my x. And I'm running out of space to find the x. I'm going to just go ahead and erase this to make room. I'm going to go ahead and take this equation, and I'm going to plug in the y into that equation. I'm going to go ahead and write that over here. 6x minus 2y equals 34. And I'm going to plug in the negative 8 in for y. and then solve. So the negative 2 times negative 8 will give me positive 16, all equal to 34. Then I just got to subtract 16. Okay, and what is 34 minus 16? 34 minus 16 is 18. Which then from there you just divide by 6 and voila, x equals 3. And there you go, x equals 3, y equals negative 8. You have what you're looking for, you're done. Again, if you have any questions later on, you just ask me in person. But for now, let's move on to multiplication of matrices. That was weird, but moving on. Matrix multiplication. Now here's the thing about matrix multiplication. If you have two matrices, A and B, they can be multiplied only when the middle part of both orders match. And the order of the matrices does matter. Now let me explain. Let's say I have matrix A and matrix B. Let's say I want to multiply the two matrices so that matrix A is in the front and matrix B is in the back. Now, okay, beeping's done. Now, the only way to determine if you can multiply two matrices is if their middle dimensions match. And in this case, since the middle dimensions are 3, that means we can multiply. So yes, we can multiply. And something else you need to know is, okay, so what if I can multiply A and B together? What would be the dimensions? Or in other words, how many rows and how many columns would my final product have? And that, ladies and gentlemen, is answered with the outer dimensions, meaning that when you multiply A and B, it should have 2 rows and 1 column. So please keep a mental note of this example, that you can only multiply two matrices when their inner dimensions match. And when you multiply, your final answer will have these many rows and these many columns. Now, to emphasize the fact that order does matter, let's say, for example, instead of A times B, let's say I want to do B times A, this time where the B is in the front. They're still the same matrices, they're just being flip-flopped. Let's check the inner dimensions. Uh-oh, the inner dimensions do not match, meaning it is not possible to multiply these matrices when the B is in the front. Only when the A is in the front can we multiply these. So please, always check the inner dimensions. And if they do not match, then you can't multiply. Now, to go over some examples of matrix multiplication. Now let's say we have these two matrices, matrix A and matrix B. We want to find matrix A times B if it is possible. Well, we first need to determine if it is possible. Let's look at matrix A. Let's look at its dimensions. It has 3 rows and 2 columns, meaning its dimensions are 3 by 2. Now let's look at matrix B. It has 2 rows and 3 columns, so it makes it a 2 by 3. Oh, lucky us. Look at those inner dimensions, they match. So that means we can multiply. But wait a minute, if I can multiply, how many dimensions will my final answer have? Well, it tells you right here with the outer dimensions. Our final product will have 3 rows and 3 columns. So let's go ahead and make a really large matrix. And let's make it so it has 3 rows. And then let's make it so that it has 3 columns. There you go. Row 1, row 2, row 3. Column 1, column 2, column 3. And then let's go ahead and fill in the rest of the spots with lines. All right, so now that we've checked, these two can be multiplied and we know the dimensions of our final answer. Now let's get to multiplying. Now, it's been a while since we've multiplied, so you might need a refresher on how to multiply matrices. So let's say we want to find the first element. And notice how this element is in the first row and then the first column. This is actually important. Since this element is in the first row, first column, that is actually telling us exactly which row and which column to multiply. So again, look at this. First row, first column. When you see first row, that means, oh, I got to take matrix A and take its first row. This is telling us, oh, I got to look at matrix B and take the first column. So then this row and this column is what will be multiplied. More specifically, the 2 and the 5, they are the first numbers, so I will multiply them first to get 10. Then I will multiply the -3 and the -4 to get 12. And once you have those two numbers, all you have to do is add. And you will get that first element. Now, just to practice, let's say we want to look at the next element. If you notice, it's still in the first row, but this time it's in the second column. Again, use these as cues to tell you which row and which column we need to look at. So again, this one is first row, second column. First row should tell you, I got to look at matrix A, look at the first row. This should tell you, I have to look at matrix B and then look at the second column. And then from there, once you identify which row and which column to look at, you just have to multiply. You'll multiply the first elements together, 2 and 0 to get 0. Multiply the last elements together, and you'll get -3. And then all you have to do is just combine those like terms. I'll do 2 more with you, and then you can do the rest on your own. So then this one has first row, but now it's third column. And again, use those as your cues to know which row and which column to use. First row, so first row matrix A, and then third column, which means I got to take the third column of matrix B. Rows always go first, columns always go second. So then let's circle those. Well, no, we've already circled. Now let's multiply. Multiply the first elements to get -4. Multiply the second elements to get -9. Then you just have to add those together. Now just one more so you can get the hang of it. Let's go over to this one now. Now notice that it's in row 2. And then the column it's in is column 1. Again, use these as our cues. This time, since we're row 2, that should tell us that we got to go to row 2 in matrix A. And then column 1 here will tell us, oh, I got to look at column 1 of the second matrix. So then we'll multiply these two matrices together. You'll multiply the 4 and the 5 together to get 20. Then you'll multiply the -1 and the -4 together to get 4. And then you just add those together and go from there. So from here, I think you can figure out the rest on your own. I'm just going to go ahead and do the rest real quickly. So then you can check your answers later. So third row, first column, third row, second column, third row, third column. Okay? So then second row, second column, that would give you 0 and -1 to add those together. And then second row, third column would give you -8 and -3 to add those together. And then third row, first column, you multiply those, you'll get 5 and 0 to add together. And then third row, second column, that will get you 0 and 0 to add together. And third row, third column, that'll get you -2 and 0 to add together. All right. And then once you've taken care of that, all that's left for you to do is to actually add up all the numbers together. I'm just going to go ahead and write the numbers in the corner. For the first element, 10 plus 12 will be 22. And then you'll have -3. Then you'll have -13. Give me a second. I'm going to write that a little bit bigger so you guys can see it. There we go. So 22, -3, -13. And then the second row, you should have 24, -1, -11. And the third row, you should have 5, 0, and -2. So then this would end up being your final answer for this matrix. So it's been a while, but with that nice review, you should be able to easily be able to multiply two matrices, depending on their dimensions. Moving on to the next example. Given the two matrices, find B times A, if it is possible. Notice how this time we still have the same two matrices, matrix A, matrix B, but now we're multiplying it so that the B is in front. And since B is in front, you better rewrite it so that matrix B is in front. Because again, order does matter. So matrix B is in front, and we're going to multiply that by matrix A, which is now in the back. So 2 times -3, or no, 2 -3, 4 -1, 1, 0. And before we multiply, we better check to make sure we can even multiply these. Matrix B is a 2 by 3, meaning it has 2 rows and 3 columns. Matrix A is a 3 by 2, meaning it has 3 rows, 2 columns. Good thing we checked. We can multiply these together. And when we multiply them, the product should have 2 rows and 2 columns. So I'm just going to go ahead and draw a 2 by 2 matrix off to the side, right here. So then let's go ahead and use that and multiply away. Okay. Actually, I'm going to make that a little bit bigger. Okay. So now, again, 2 rows, 2 columns. First, row, first column. First row, first column. Meaning, with the first row, I'm going to take my first matrix, B, take its first row, and multiply. Then for the second matrix, I'm going to take the first column. And even though there's now 3 elements to multiply, you still multiply them in a similar way. You'll multiply the 5 and the 2 together, and that will give you 10. Multiply the 0 and the 4 together to get 0, and then multiply the -2 to the 1 to get -2. And you will still add them together like always. And I think you guys can do the rest from here. Again, I'm going to do it real quick so you can check later. First row, second column, second row, first column, and then second row, second column. If I multiply the first row to the second column, they'll give me -15, 0, and 0. Okay. And then for second row, first column, that'll give me -8, 4, and 3 to add those together. And then second row, second column, that'll give me 12, and then -1, and then 0. And then if you add all those together, your first element should be 8, second element should be -15, your third element should be -1, and your last element should be 11. And that would be your answer for multiplying these two matrices. Okay, so there's just a couple more quick examples I want to show, and then we're done. So next slide. Given the two matrices, multiply A times B if possible. Again, matrix A should be in front, and it already is, so we're good. And then matrix B is in the back. Let's check the dimensions. Matrix A is a 2 by 2. Matrix B is a 2 by 1. And double check the inner dimensions. All right, it works. And for our final answer, we should have 2 rows, 1 column. So let's go ahead and write that out. So just to make sure, I have 2 rows, 1 column. And then from there, to find the elements, do exactly what we've been doing before. First row, first column. And then here will be second row, and first column. Okay, so for the first matrix, we're going to take the first row. And then for the second matrix, we're going to take the first column, which, of course, is the only column. So then multiply the elements. 8 and -1 will become -8. And then the second 8 and the second 8, multiply those to get 64. Then just add those together. Then for the next one, we'll do second row and then first column, which has already been circled, but I will circle it again. Then multiply the first elements, -3 and -1 to get 3, -1 and 8 to get -8, and then combine those. So then, adding the numbers, -8 plus 64 should give you +56, and then 3 plus -8 should give you -5. And there you go. There's your matrix, all done. One more, and then we are done. Okay, next one. Same two matrices, only this time we want to see B times A. Since the B is in front, you better write that B in front. If you don't, I will haunt you in your sleep. Here we go. -1, 8. Matrix B is in front. Then multiply by matrix A, which is an 8, 8, -3, -1. Okay, First, let's make sure the dimensions work. B is a 2 by 1, and matrix A is a 2 by 2. Let's check those inner dimensions. Uh-oh, they don't match. And if the inner dimensions don't match, it's not possible. And you don't have to do anything else from there. Congratulations, you are now officially ready to do the online homework for 10.4, the Algebra of Matrices. Thank you very much, college algebra students, and I will see you later.